Greeting friends, in this video we are going to talk about the remaining reactions of glycolysis, that is the 8th, 9th and 10th reactions. So in the course of video we would finish the glycolytic reactions. So the first reaction of the video is the 8th reaction, where we convert 3-phosphoglycerate into 2-phosphoglycerate. So there is shift of phosphoryl group. That shift is from the 3rd carbon to the 2nd carbon. This phosphoryl group is transferred to the 2nd carbon. The enzyme responsible for this shift is mutase. Phosphoglycerate mutase requirements are Mg2 positive. The reaction mechanism of this reaction is similar to the second reaction of glycolysis, that is the conversion of glucose 6-phosphate to fructose 6-phosphate, that is the isomerization reaction, and that is acid-base catalysis. Acid-base catalysis, where we are going to see that acid is donating the proton and the base is abstracting the proton. So we are going to see that here. So this is 3-phosphoglycerate, and on the enzyme, on the mutase enzyme, there are histidine residue groups present. So histidine residues are present on the enzyme. We are interested in 2 histidine residues, in which one histidine residue is containing phosphoryl group. So this histidine residue is going to give off its phosphoryl group to the 2nd carbon. So we are talking about the first step. The 2nd carbon it gives, okay, and this second histidine, active histidine residue, is acting as base catalyst, general base catalyst. So it is going to abstract the proton from here, okay. So what it becomes, you can see here, the phosphoryl group is transferred to the 2nd position and the proton is removed. In this second case, in the second step, I must say, the second active histidine is now containing that hydrogen has become acid catalyst, okay. It would act as general acid catalyst, and this, which is devoid of this phosphate group, the phosphoryl group has been transferred from here to here, so this is devoid of this phosphate group, is going to take back its phosphoryl group, but now from this position, 3rd position, 3rd carbon number. This is now going to take back its phosphoryl group, and in the meantime what this second residue is going to do, it would give back its proton, okay. So what we are going to get, this 2-phosphoglycerate, hydrogen is here, it becomes OH, and phosphoryl group what we wanted in the initial stages of this reaction, that is 2-phosphoglycerate. So the position has been shifted, we are ending up with 2-phosphoglycerate. Next reaction of glycolysis is the 9th reaction, where we convert the 2-phosphoglycerate into PEP, that is the phosphoenol pyruvate, by the removal of water. Let's see this reaction. This is the 2-phosphoglycerate compound produced in the 8th reaction. Now we are going to remove this water molecule from here, and it would result in the formation of PEP. The enzyme here is enolase. This is removing this water molecule. We discuss a bit about this enzyme because this is the first time we are seeing this enzyme. Enolase, also known as phosphopyruvate hydratase. Phosphopyruvate hydratase, because hydratase, why? Going to remove the water. This enzyme belongs to the family of lyases. What are lyases? Lyases, the enzymes which cleave simply, okay, and more specifically this is hydrolysis. we are interested in removing the water molecule. So hydrolysis, these enzymes are responsible for the breakage of the bond that is occurring between the oxygen and the carbon. So this particular enzyme enolase is going to remove this water molecule from this 2-phosphoglycerate and would make it into the PEP, that is phosphoenol pyruvate. What is interesting point about this 9th reaction is that these two reactions, 9th and 10th reactions, are pretty similar to the reactions which we have done before, that is the 6th and 7th reactions, in which we increased the energy content of the molecule, that was glyceraldehyde 3-phosphate. We increased the free energy content of that molecule by phosphorylating it. Here we are doing the same thing, but we are not phosphorylating it. This 2-phosphoglycerate is a compound with low phosphoryl transfer potential. That is, the free energy of hydrolysis for this compound is only minus 17.6 kilojoule per mole. But after the water molecule is removed from this compound, what we are ending up with? Phosphoenol pyruvate. This is a compound with high phosphoryl transfer potential. That is, the free energy of hydrolysis for this particular compound is very huge, too huge, and this is minus 61 kilojoule per mole. So we are increasing the content. Why we are increasing it? Because if we see this 10th reaction, which is catalyzed by pyruvate kinase, the enzyme which is going to transfer the molecule of phosphoryl, or we can say phosphoryl transfer, this is also bidirectional, because in this case it is going to transfer the phosphoryl group from the substrate to the ADP. The last instance where we saw this kind of process was the 7th reaction, where we converted the 3-phosphoglycerate into 1,3-bisphosphoglycerate into we say the 3-phosphoglycerate, and we transferred the phosphoryl group to ADP. Okay, so that was substrate level phosphorylation, because substrate is itself providing the phosphoryl group. This is the same second instance of substrate level phosphorylation, because the substrate is provided by the substrate, and we are ending up with the another molecule of ATP, and the final product is pyruvate. Okay, so this was all about the glycolytic reactions. What more is here, that this pyruvate, before it is converted into this form, there is something else, that is the enol form. Enol form is the first form that is produced when it is converted to this pyruvate form from PEP. Then it readily tautomerizes into its final form, that is the keto form. So this is the form we are interested in. So now when we have finished with glycolytic reactions, what we are going to do? We want to see what did we get, what is the result of glycolysis. So to account for that, we can make a balance sheet, okay, for the glycolytic process, that is the overall balance sheet. And for this we are going to account for three things. The first is the fate of carbon atoms of glucose. Of course, we started with glucose. This is the pathway of, we call it the pathway of C atoms. The second, we are going to count the, we can say, fate of phosphoryl groups, or the pathway of phosphoryl group. The third one is the transfer of electrons. Transfer of electrons, that is redox reactions. Redox reactions, or simply reduction or oxidation. This would be the pathway of electrons. So we are going to make an overall reaction for all these things. Okay, how we started? We started with glucose. What did we use in the preparatory phase? 2 ATPs we invested. And what more? We end up with 4 ATP. 4 ATP we used in the payoff phase. And what did we use else? 2 PI. Each one for, we can say, glyceraldehyde 3-phosphate, and we used 2 NADs also. One each for glyceraldehyde 3-phosphate. The result is glucose is converted to pyruvate. So 2 pyruvate, and for ATPs it is ADP, 4 ATP plus 2 NADH plus 2 H positive ions, and what more? 2 molecules of water. And if we cancel the common terms, we are going to get 2 ATP, here 2 ATP, 2 ATP. So the overall reaction is the 2 ATPs are produced. Okay, what we can say overall is that for the pathway of carbon atoms, glucose is converted into pyruvate, glucose 2 pyruvate molecules for the pathway of carbon atoms, and for the pathway of these phosphoryl groups, 2 ADP plus 2 PI resulted into 2 ATP. For the pathway of electrons, we can say that 4 electrons as hydride ions are transferred from where? 2 molecules of glyceraldehyde 3-phosphate to 2 molecules of NAD, okay, are transferred from 2 molecules of glyceraldehyde 3-phosphate to 2 molecules of NAD to make it NADH. So now we are going to talk about the fate of NADH, because we want to reoxidize it to continue the glycolytic reactions. Okay, so 2 NADH plus, where it is going to donate its electrons to make itself as NAD, to electron transport chain, and the ultimate receiver is the O2 plus 2H positive. So the result is 2 NAD plus 2 molecules of water. So this is all about glycolytic reactions and their result at the end. In the next video or in the next lecture, we would be talking about the fates of pyruvate. Thank you.